All right, so hello. Here's section 4.1, the third video about complex numbers. So here's an example of where complex numbers come into play. If you have this equation, x squared plus 4 equals 0, you could try to solve this a few different ways. You could try to factor it, but you'll find that you can't factor x squared plus 4. You could use a quadratic formula, and I'll do that in a second. But before we do that, I want to try to solve it by graphing. So to do that, we're going to graph y equals x squared plus 4. And we want to see what are the values of x that make y equal to 0 here. So what are the x-intercepts? And so here's the graph, and you see, oh, it opens upwards and never crosses the x-axis at all. So there are no values of x that make x squared plus 4 equal to 0. So you could just say there's no solution here, and that would be basically right because of the way the graph looks. There's no values of x that make y equal to 0. So, yeah. But what if we try to use the quadratic formula? What will happen with this? So if you do, we could write this as x squared plus 0x plus 4. That way, that's your value of b is 0. And then we could use a equals 1, b equals 0, and then c equals 4. Plug it into the quadratic formula. We're going to have x equals negative 0 plus or minus the square root of b squared, 0 squared, minus 4 times 1 times 4. So it's b squared minus 4ac there. All divided by 2a is 2. And then let's see what happens. You get the 0 squared is just 0. So we have plus or minus negative 4 times 4. That's going to be negative 16 over 2. And what is the square root of negative 16? It doesn't really exist. It's not a real number. So what we're going to have to do is invent a new kind of number called imaginary numbers that we can use to describe this. So this is what we call I, also known as the imaginary unit. It's the square root of negative 1. So it's not a regular old real number that you can put on the x-axis or on the y-axis. But it's a new kind of number that's just as good as regular old real numbers. But we're not going to go into too much detail about how cool imaginary numbers are, because imaginary numbers are great. But what we will say is that if you do I and then square it, what you get is negative 1. And if we use that as I, we can actually take this thing and simplify it and write this as the plus or minus square root of negative 1 times the square root of 16, because that negative 1 times 16 is negative 16, and then divide that by 2, and then we'll have plus or minus the square root of 16 is 4, and then the square root of negative 1 is I. You can divide that by 2, and you end up with plus or minus 2i here. So we still can describe the solutions of this. The solutions are not regular old real numbers. They're these fancy new kind of numbers called imaginary numbers. So you could either say no solution, or you could say it's plus or minus 2i. But you should be able to deal with imaginary numbers like this every once in a while. Here's an exercise for you to get a little practice with this. Um, you're going to subtract the 9 from both sides, and so you'll have a negative 9, and then you'll be taking the square root of negative 9. And you can still check your answer in the book with this, but definitely do it on your own. And in the next video, we'll look at how you can tell, just based on the A, B, and C here, whether or not it has no real solutions like this one, or one or two real solutions.